All right, welcome back. Happy Friday. So I've just returned the tests. Generally, the tests went quite well. The median grade was 80, so right in the middle was 80. So when you're finished looking at the test, go ahead and throw it back in the green folder for right now. I'll give it back to you on Tuesday for keeps. Also on your tables, you will notice something called practice problems for the final exam, so grab a copy of that handout. So the final exam is coming, and for the first time since all the times we've looked at the calendar, we're at the end of the page, right? Like the exam is just around the corner. So this is another resource that I wanted to share with you. I did not make this. This is something created by Peter Rosnick, who was full-time for a long time, then he was dean, and now he's teaching again here. So anyway, that's his, so I give credit to him for that. Also, if there are any typos or errors in the answer key, I give blame to him for that. I had nothing to do with this document. I just photocopied it, and it's yours, okay? And I don't have any videos or other resources related to that document. So here's the plan, gang. We have 4 classes left of new material. You will notice that the word fraction is inside of each of these 4 classes. So for today and all of next week, talking all about these things called algebraic fractions. Then on May the 12th, we have our 5th and final quest, which is basically just going to be on the stuff we're going to do with fractions. Then we have a review day for the final. That's the last day of the semester, May 14. And then our exam is on Monday, May 19, 8 until 10 a.m. Questions on the calendar? Okay, so I will say that you know, there's less than 3 weeks left in the semester. Like I said, our final exam is on a Monday. 2 weeks from this coming Monday, this class will be done. So I know that many of you are tired and some of you have been sick and aren't feeling all that well, and you've got a million responsibilities and a million classes and job, family obligations, and all kinds of other stuff taking your time. This is the time to find those hidden reserves of energy. This is the final push to the finish line. One more quest and then a final exam means that there's an opportunity for each of you to raise your grade in the coming 2 weeks and a couple of days. On the flip side of that, there's also a chance for your grade to drop precipitously if you are not working, if you can't find the energy, find the strength, find the time to finish strong, right? So we're almost at the finish line, but I'm hoping that you've got enough left to give one last sprint to that finish line instead of crawling across it, okay? Again, lots of resources at your disposal: Math Studio, my office hours, peer tutoring, each other, all those videos on YouTube. Okay, so let's jump in on page 73, and we're going to run up here to the top, number 1. And it talks about this new concept called algebraic fractions. So you know the word fractions, but we've thrown this word algebraic in the front. So what does that mean? Well, here are 3 examples of algebraic fractions. If I just said name a fraction, you might say something like a half or 2/3. You'd be naming things with a number over a number. Algebraic fractions involve x's. And so what makes these things algebraic fractions and not just ordinary fractions is they include 1 or more x's. That's it. So for the next 4 classes, we're going to be looking at fractions that involve x's, variables. Okay, let's come down here and start filling in some of this chart. We're going to skip a little bit of the text here. Jump down to number 3. So we've got our algebraic fraction in part A, 5 over x squared. And what I'd like to do is find the value of that fraction, or evaluate that fraction, at x equals 2. So all that means is we're going to plug 2 in for that x. So 5 over 2 squared, which is 5/4. So evaluating is no easier or harder than it's ever been. You just plug in the value of x. Let's fill in the next column, which is the value of that same fraction, but at x equals 5. What do we get here? 1/5. So far, so good. Okay, let's jump down to part C. We'll skip B. and go ahead and plug in the same x equals 2 for both x's. See what we come up with. Upstairs is a 9, downstairs -3. Any questions so far? Go ahead and plug x equals 5 into that same fraction. Upstairs, 12. Downstairs, 0. What does that mean? We're dividing by 0, which you've been taught from a long time ago is not allowed. So usually the word we use is undefined. Not allowed to divide by 0. Okay, so let's try number 4 here. It says, for what values of the variable is that fraction not defined? When is it not defined? So what we've just seen is that something is undefined or not defined when there's a 0 where? Upstairs or downstairs? Downstairs. So you could care less about the 5x that's sitting upstairs. It's irrelevant. It could be anything. You just need to worry about the bottom. So what you're looking for is places where the bottom is equal to what bad number? 0. And that's all that we have to do is figure out when the bottom is equal to 0. So let's write that down. X squared minus x minus 6 equals 0. So this is what we have to solve. Whatever value or values of x we get is the answer to this question. So far, so good? Okay, but that's a quadratic equation. I see the x squared. We've spent a lot of time solving quadratic equations. So we're going to solve this quadratic equation using the same techniques you used on test from Wednesday. Well, let's say this. You could solve every quadratic equation in the world by using what powerful formula? Quadratic formula. But if you're lucky, then the quadratic is factorable, right? And so if it factors, oftentimes that's quicker and maybe less prone to error than the quadratic formula. And so on one of the pages on the test, I said solve these quadratic equations. There were 5 of them, and some of you used the quadratic formula 5 times. I feel like some of you are a little bit too tied into the quadratic formula at the expense of anything else, like in an exclusive relationship with the quadratic formula. Like, no chance I'm going to factor, no chance I'm going to take the square root of both sides. I am seeing the quadratic formula and we are not seeing other people. It might change your Facebook status, actually. In a relationship, quadratic formula. But the problem is the quadratic formula is quite big and complicated, and there's a lot of places you can go wrong in it. And so when some of you went wrong with little arithmetic mistakes here and there in the quadratic formula, I hit you with some points off on this test because the quadratic formula is not the best technique for every single quadratic equation. So this is an example of one where it's just so much better to factor. And the funny thing was, many of you factored quite competently on the previous page. But then when it came to solving the equations, had no interest in factoring, all quadratic formula. Okay, x and x, looking for 2 numbers that multiply to what? -6, and add to -1. There aren't that many options. What are the 2 numbers that do that? -3, +2, right? And then we set each piece equal to 0. We've got our answers. X equals 3, x equals -2. As a quick check, if we plug 3 in for this thing, Upstairs, we get 5 times 3. Downstairs, 3 squared minus 3 minus 6. Yes? Changing those x's to 3's. Upstairs, 15. Downstairs, 9 minus 3 minus 6. 0. That's what you built. You made it 0 downstairs. You made it not defined. Questions on that? Okay, take a look at number 5. We're going to go back to an ordinary fraction with just numbers, no x's in this case. And it's going to cue us in on something that we're going to be able to do on the next page when there are x's. So what I want to do is reduce this thing. But I'm going to write out maybe a little bit more detail than you normally would if you just had to reduce an ordinary fraction. What I'm going to do is look for the biggest number that goes into both 24 and 54. So I know that 2 goes in, but I'm going to be as greedy as I can be. Is there anything bigger than 2 that goes into both? 6 goes into both of those numbers. Yes? So what we're going to do, so a lot of times you would just do this. You'd say, oh, okay, divide this guy by 6, and that's a 4. And you divide this guy by 6, and that's a 9, and that's your answer, right? 4 over 9. But I'm going to write out a little bit more detail. So here we go. 24 over 54. I'm going to take that 24 and write it as 6 times something. What is it 6 times? 4. What's the math word that describes what we just did to the number 24? I factored it, right? Factor means take it and write it as a product. So we factored the number 24. We're going to likewise factor the number 54 using the same 6 times 9. Now there are a lot of ways to factor 24. We could have done 12 times 2, but we chose to factor it with the 6 because we saw that 6 was the biggest thing that was in both. Okay. And even at this stage, I'm going to do more work than is necessary because you can just cross off the 6's and you get to your answer, right? But I'm really going to do the details here. I'm going to write this as 6 over 6 times 4 over 9. And the reason you should believe that's okay is that if I gave you this finished thing and I said multiply, well, how do you multiply fractions? Just straight across. And that's exactly where it came from, right? So we buy. I mean, it's like kind of a weird way to write it, but it's valid. And then I'm going to look at 6 over 6 and say, oh, what is 6 over 6 really equal to? It's really equal to 1. And then I'll write the 4/9 over here. So 6 over 6 is 1. That's really what's going on. Like you can only cancel because you see a version of the number 1 there. And multiplying a number by 1 doesn't change anything. So it's okay to ignore it. But that's really why we're allowed to just cancel those 6's. Okay, so we're about to do the same process, but to algebraic fractions, ones with x's in it. What was the first step with the number 24 and 54? Is to factor. You factored first, and then we looked for something that we're about to call a fancy form of 1. 6 over 6 is just a fancy way to write the number 1, right? And so we're going to be looking for things that are just exactly the same on top and bottom and say, oh, that's really just a 1. Okay, first giving credit. We're going to call FFOO, fancy form of 1. We're going to call that a foo-foo, named by this particular author in a publication called The Mathematics Teacher. So foo-foo, fancy form of 1. And let's give it a shot here in the table. So the big question, first step, are the numerator and denominator in factored form? So look at part A here. X squared minus 9. Is it in factored form? Meaning, is it one thing times another thing? Not at the moment. Right now, it's a subtraction. How about the bottom? Is the bottom one thing times one other thing? No, it's a couple of guys added together. So if the answer is no, if they're not in factored form, you cannot reduce until it is factored. So step 1 is always going to be factor the numerator and denominator completely, separately from each other. So let's factor. So answer to the big question, are they both factored? No. So that means we're going to factor everything. So this guy becomes So I'm just going to get my shell up here. First thing you look for any factoring problem is to see if there's something that goes into all the terms. Is there anything you can factor out from x squared and 9? Yeah, we're going to factor it in that way, but there's nothing that goes into both of those right now. Like there's no number that goes into both. There's not an x in both. Same thing on the bottom. There's nothing you can factor out of everything. So we just go to our ordinary factoring. So x squared minus 9, that's one of those difference of two squares examples. X plus 3x minus 3 in either order. That's one of the kinds of things that we can factor. And then downstairs, it's a product sum question. That's right. So two numbers that multiply to 9 and add to 6, both 3. So x plus 3, x plus 3, which you could write as x plus 3 squared. Okay, again, what did we just do to both the top and the bottom? We factored. And now that it's in factored form, all we are looking for are foo-foos, fancy forms of 1. Do you see a fancy form of 1 anywhere in this fraction? You do. X plus 3 on the top, x plus 3 on the bottom. That is a fancy way to write the number 1. So say, oh, there's no need to write extra stuff in our answer. And get rid of that, and we'll just write the final answer. X minus 3 over x plus 3. And I'll say that it still looks like we can cancel some stuff. What looks like it cancels? Maybe the x's, maybe even the 3's. None of them cancel. The only way you're allowed to cancel is if things are in factored form, multiplication form. You cannot cancel here in the same way that if I gave you like an 8 minus 3 over 8 plus 3. Okay, forget the idea of canceling, but what's the answer? Upstairs is 5, downstairs is 11. That's the answer, yes? If you try to cancel, do you see, like if you cancel the 8s, does it look anything like 5 over 11? If you cancel the 3s, like is there anything you can think of to do where you cancel stuff that looks the same and get to 5 over 11? I don't see anything you can do. It's because you can't cancel when it's addition or subtraction. So make sure you avoid the temptation to just cancel things. If there are addition signs or subtraction signs, you cannot cancel. Only multiplication. For the same reason, you couldn't go to the original and say, oh look, x squared on top, x squared on the bottom. Just cancel them. You can't, because there's subtraction, because there's addition. So the only way you can cancel is by factoring. Okay, so let's move on to part B. 3x plus 12 over 6x plus 24. I see lots of things that I want to cancel. Is it allowed right now? It's not, because there's an addition on the top, addition on the bottom. Nothing is ready to cancel. So instead, what do we do first? Factor. So let's factor. So this guy equals. The first step in factoring is always to look to see if there's something that goes into every term. Is there anything that goes into 3x and 12? It's 3, which means this is going to be one of those where there's a 3 in the front and just one set of parentheses, not 2. So what's in the parentheses? X plus 4 is good, right? Just pull that 3 out. You don't get rid of it. You still have to write it, but you pull it out. And then the same game on the bottom. What can we pull out of both? So pull the 6 out. And lo and behold, another copy of x plus 4. Are things cancelable right now? Why is this okay to cancel? Because it's multiplication. Put the dots in just to convince you. This is a times and a times. That's why we're allowed to cancel. And I'm not bothered by the fact that there's addition inside the parentheses. I'm not looking in there. I'm not looking to just cancel the 4s. That's not allowed. But if I see multiplication and then 2 copies of exactly the same thing, I can cancel. And so even though the x plus 4 has addition inside of it, I just see 2 copies of the same thing. And so we get rid of both of them. And so our answer here, 3 over 6, which of course you reduce to 1/2. Okay, so why are we playing this game with the fractions? Well, oftentimes scientists and mathematicians have complicated expressions that they need to manipulate. Would you guys agree that if you had a choice between working with this thing in the midst of some larger problem or working with this thing in the midst of the larger problem, you'd rather work with the half? Just way simpler, right? And so all we're doing is simplifying, just maybe a simplifying you haven't seen before. But scientists are quite interested in knowing all the different ways to simplify so that they can make progress on these really big problems. That's what we're after. Okay, looking down here at part C, 2 plus x over 2. So first question, can I cancel the 2's? No. One of the 2's is ready to be canceled. Which one is fair game to cancel? It's the one on the bottom. It's just a solitary 2. But the one on the top has an addition sign right next to it. It is not ready to cancel. So if I can't cancel yet, then I factor. Can we factor 2 plus x? There's nothing to do with that. There's nothing to factor out. It's not an x squared. You can't factor anything upstairs. 2 on the bottom is just plain 2. So, okay, I guess it's technically in factored form. There's nothing to do. So what's the answer to this problem? It is itself. You can't simplify this. Have we used CBS for cannot be simplified? I don't remember. Yes? Okay. Can't be simplified. If you want to copy it as it is, you can copy it. Just like on the test, where I gave you a whole collection of things to factor, and one of them could not be factored, you should expect to see the same kind of thing. I give you a whole bunch of things that I want you to cancel, reduce, but maybe one of them you can't reduce. I don't want you to go out and try to make up ways to reduce. If you can't reduce, then you just can't, and that's an okay answer. Yurka? Correct. When there's addition or subtraction, you cannot cancel. Only multiplication. Okay, let's take a look at 7, which has us thinking about this algebraic fraction, x minus 3 over 3 minus x. Same thing, but kind of reversed. So what I want to do is plug in x equals 10 for both x's. And then separately, I want to plug in x equals negative 5 for both x's. So with your neighbors, plug in x equals 10, and then separately plug in x equals 5, and let's see what we get. Okay, what did we get when we plugged in x equals 10 and reduced? Negative 1. What did we get when we plugged in x equals negative 5 and reduced? Negative 1. Both of them give negative 1. And any number will give you negative 1. Because think about it, upstairs and downstairs were the same number, right? Just one was positive and one was negative. And it makes sense because you're just doing the same calculation but in reverse, right? You're just subtracting the same numbers but in reverse. So you'll get the same thing both times, just one will be positive and one will be negative. And so it turns out that's always true, and it's going to be useful to us. So here's the more general fraction, a minus b over b minus a. If you ever see a minus b over b minus a, you say, oh, that's really just negative 1. Right? It's not a fancy form of 1, it's a fancy form of negative 1. So we're going to use that fact right there. Let's try this example, the 64 minus x squared. Can I cancel the 64 with part of the 16? Can I cancel the x squareds? Why not? Not factored. Needs to be multiplication, not addition or subtraction. So let's factor. Equals. I'm going to set up my two sets of parentheses. Well, I guess my first thing is, does anything go into all the terms? And the answer is no in this case. So let's start upstairs. 64 minus x squared. I know I said repeatedly I always like my x squared to be positive, and so some of you have followed my lead and would always move that negative x squared to the front and then try to work with it there. I guess I got to backtrack a tiny bit. I love my x squared to be positive unless it happens to be one of these difference of two squares, in which case I don't care. I just need two numbers that give me 64. It's got to be the same number, 8 and 8. And the two numbers that are going to give me x squared, the two letters, I guess, x and x, 1 plus 1 minus, right? It's not wrong to bring that minus x squared to the front, but you don't need to. Not if it's a difference of two squares. Okay, downstairs, a little bit tougher. Start by putting x's in the front. Two numbers whose product is negative 16. The sum is negative 6. There aren't that many choices. 4, negative 4, 8, negative 2, negative 8, positive 2, and that's the winner right there, right? Product is negative 16. Sum is negative 6, so we just take them and throw them into our parentheses. Okay. As you can see, the stuff that we spent all that time learning about factoring, it hasn't disappeared. Like we're just bringing it into these larger problems now. All right, so everything is factored, so things that look exactly the same can cancel. So this question you got to think about very carefully. Is there anything that's exactly the same upstairs as downstairs? There's nothing that's exactly the same. Is there anything that looks like what's circled up there in blue, where it's the same, but just reverse order on top and bottom? What do you see upstairs that's the same but reversed downstairs? It's the 8 minus x and the x minus 8. You guys see that? That's the pattern that you've established is really equal to what magic number when you divide those two? Is negative 1. And so we cancel them, but you got to be really careful. I'm going to put big negative 1 up there. You don't just cancel them and ignore it. Say, oh, cancel, and the answer is negative 1. So our final answer, I guess I'll just shuffle that negative 1 to the front. Victor. You could put the negative 1 on top, which is where I put it. Just as well, you could put it on the bottom, not in both places. Or you could put it in the front of the whole fraction, negative 1 out there if you want. The whole thing has to be negative of what it should be. So wherever you put that negative 1 is totally fine. Can we cancel the x's? Can we cancel the 8 and the 2? No, we can't go inside of parentheses to cancel. That's it, that's our answer. So the only new thing is you're looking for stuff that's exactly the same top and bottom. Fancy form of 1, you just cancel. But now add to your list of things that are cancelable, things that look exactly the same on top and bottom, but one of them is just the reverse, right? A minus B on top, B minus A on the bottom. Cancel, but you gotta put that negative 1 in. Okay, so we've said all we're gonna say about reducing single fractions. So now that we're done playing with single fractions, we're gonna now start to combine two fractions. And there are a lot of different things you can do with two fractions. You can add them, you can subtract them, you can multiply them, and you can divide them. Yep, that's what we're about to do. Turns out a couple of those are easier than the other two. And so we're just gonna focus today on multiplication and division, which surprisingly are easier than addition and subtraction. So let's take a look at number 9. Going back to ordinary fractions, just numbers, no x's. 4/9 times 18/8. How do we multiply fractions? Straight across. Anybody know 4 times 18 off the top of your head? It is 72, but that's a little bit of work if you don't have a calculator. On the bottom also happens to be 72, and then you reduce. Far better than multiplying straight across first is to do what? Is to reduce. Before you multiply, reduce. So let's start canceling. Let's see. 4 and 8 become 1 and 2. So far, so good. 18 and 9 become 2 and 1. And so then the whole thing just becomes 1 times 2 over 1 times 2, which is just plain 1. So the lesson of this story is, yes, when you multiply fractions, you go straight across, but way better is to first cancel. Anything you can cancel on top and bottom, you do it first before you multiply. What division? 4/9 divided by 2/27. Which one do we flip? Second one. You guys remember that? So you copy the first guy. Division becomes multiplication. And then you flip the second guy. And now it's a multiplication. And we know how to multiply fractions. Straight across. 4 times 27. Is that what we should do first? We should reduce first. Not wrong, but way better is to reduce first. So for example, 4 and 2 become 2 and 1. 27 and 9 become 3 and 1. So our final answer, 6 over 1, which is just 6. Okay, so that's how we multiply and that's how we divide. Real quick, but we're not going to do it today. How would you add those two fractions? We got to find the lowest common denominator, right? Which is quite a bit more complicated than multiplying and dividing fractions. That's why it's harder to add and subtract, is because you got to get the same denominator. So we will do that next week. But today, just multiply and divide, because those are the easier ones to do. So let's go to 11. Find each product or quotient. Part A. If it helps, I can force this to look like a fraction by introducing 1. Okay. Now it's true, we could just multiply straight across, but I really like this idea of reducing first. So for example, 15 and 35 both share a 5. So what do they become? 3, 7. And then we're going to get rid of an x. So upstairs you have x squared. Downstairs you have a solitary x. So just x on top. And the one on the bottom disappears. And then I think we just have to carefully read what's left. I think that's a big part of the difficulty of playing with these fractions, is just making sure you write things big enough in the small space that you have. There's a lot of stuff that you're writing in a compact area. So just be careful as you're crossing things off that you know exactly where things end up. So upstairs, I see a 3, an x, and a 3, all times. So 9x up there. Downstairs, 7 y squared. Questions on that one? Okay, let's try the next one. All right, it is another multiplication, and you are perfectly welcome. I'm going to put this in here. You don't copy this. But if you're going to multiply straight across, then I guess you have to do this lobster claw or box method or FOIL. You got to somehow push them all together, which will give you a big thing with a y to the fourth in it, right? Very first things you multiply will give you 4y to the fourth. And then downstairs, you got to do the same thing. And I'll say it's not wrong. What you end up with is not wrong. But what you end up with, you're not going to be able to reduce because it'll be this big massive thing with y to the fourth, and downstairs a big massive thing with y cubed. And you can't cancel anything the way that you've written it. Like, it is currently in a better form than if you multiplied it all together. Because it's currently in factored form, isn't it? I mean, like, everything is multiplication here. But if you distribute everything, you'll just get pluses and minuses all over the place. So avoid the temptation to multiply it out. It's not wrong, but it's heading you further from the final answer. That said, we can factor these things even further. So let's play with the first fraction first. Upstairs, 4y squared minus y. I'll highlight one at a time. That's what we're working on right now. Is there anything you can factor out of both of those terms? Yeah, you can take a 1 out, and if you can't take anything other than 1, then you don't factor anything out. So this must be one of those that ends up with 2 sets of parentheses, because that was our only other option. You recognize it? Who? What do you mean? Mm-hmm. You want to cancel parts of those? Okay. Yeah, so can we do that? Like, could I cancel this 4 and this 4? I know. What's that? Yeah. This thing right here and this thing right here, they say neither one of those 4s is available to you. So yes, you're perfectly allowed to cancel a numerator from the one with a denominator from the other. That's not the problem. Any numerator with any denominator is fair game, but only if it's all multiplication. And you can't pick off parts of additions and subtractions. Victor? The 4 is being multiplied by the y and by the y squared, but you can't stop reading at that point. This is one thing, right? It's upstairs inside of a fraction, and it is a subtraction problem. There's a multiplication in there, but at its heart, it's subtraction. That means I can't cancel. And it takes time to really recognize like what's allowed to be canceled. So be patient with yourselves as you figure out what does it mean to really say it's just multiplication and to say it's not allowed to cancel with addition and subtraction. Okay, but this guy is a difference of 2 squares. 2 things that are going to give you 4y squared but have to be the same. Two y and another copy of 2y. And then 2 things that are going to give you a 1, they have to be the same. Plus 1 minus 1. That's it. All right, I'll highlight the next guy. This is what we're working on now. Is there anything you can factor out of both of those terms? No. So I guess we'll just start with our 2 sets of parentheses. You recognize that pattern? Is it the same kind of thing? You see a subtraction, 2 squares, 2 plus y, 2 minus y. Okay, done with that. Moving on to this next guy. Times big fraction. Again, the first question I always ask when I factor, is there anything I can pull out of all the terms? Is there anything that's inside of y squared that's also in 2y? And there's a y. And that's what you're going to take out. So this one is going to look different than the others. It's going to be a y with 1 set of parentheses instead of our normal 2 sets of parentheses. So first we get y minus 2, that's good. And then finally, this guy on the bottom. Again, the first factoring question you always ask, can you pull anything out of all the terms? What comes out? 2. And then a single set of parentheses. Yeah, don't forget that +1. Just because the 2 is entirely factored out doesn't mean it disappears. Still need that placeholder. Okay, finishing the problem is quite a bit more fun than getting to this stage. The end is really easy. But I'll just stop here and say for a second that there's a lot of factoring involved in these fraction problems, right? You have to factor everything first. So if you are one of the people that likes factoring, then this is good news for you. If you were one of the people that thought you were done with the stupid factoring on the test, then this is bad news for you because it's still here. Okay, now it's all multiplication. I'll put in some dots. You don't need them. I'm just highlighting that everything is multiplication now, not looking in the parentheses, which means you just try to find stuff that's exactly the same on top and bottom, and you get rid of it. So is there anything exactly the same top and bottom? So 2y plus 1 up there, 2y plus 1 down there, exactly the same. Who gave us this idea before? You don't have to stay with the same fraction when you cancel. You can go any numerator with any denominator. Okay, is there anything else that's exactly the same top and bottom? Y minus 2 copied on the bottom. Is it exactly the same? No, but it's close. And that's the other kind of canceling that we had. But first, there's nothing else that's exactly the same. And then we say, okay, this y minus 2 and this 2 minus y is that a minus b, b minus a pattern that we've seen a couple of times. So you cancel them, but you got to put a -1 someplace. I'm always going to put it on top. You could put it on the bottom or front if you want. And then we're just going to write our answer. So upstairs, 2y minus 1, also y, also a -1, which I'll shuffle to the front. Downstairs, 2 plus y, as well as 2. Can we cancel this y on the bottom with one of these guys upstairs? It's inside. You can't look in the parentheses and just start picking off things to selectively cancel. Don't look in the parentheses except to decide if it's exactly the same as what's in some other parentheses. The fact is, upstairs there are 2 y's, here and here. One of them is ready to cancel if it had a partner downstairs. Which one of those y's is ready to cancel? It's the one that's outside. You can't go inside and selectively pick things apart. But the y on the outside, it's multiplication. It's ready to cancel. If there were a flat y sitting outside somewhere on the bottom, we'd get rid of them. Okay, questions on that? Yeah, Yurka. You can distribute. There's no reason to distribute. I know that a lot of times you're taught, okay, you have to distribute if you have the opportunity to. But the fact is, distributing, it will just make things bigger. Nothing will cancel after you distribute. I'm quite happy leaving this as my final answer. Okay, let's take a look at part C. What's the fundamental operation in C? Is division. And so the first step for division is to change it. So what do we do with the first fraction? Copy it exactly as it is. What happens to that division symbol? Changes to multiplication. What happens to the second fraction? Flip it over. Okay, go ahead and get the shell of the next step up. We're going to have 2 sets of parentheses for all 4 of these pieces of the fractions. So just write lots of parentheses everywhere. Okay. I'm just going to fill in the factored answers here because I want to make sure you have some time to do the group activity on the next page. So I'm just going to factor all these and you can check them later. First one, a plus 5, a minus 2. A minus 3. A plus 5, a minus 3. Downstairs, what do we have? A plus 5, a minus 2. Upstairs, a minus 7, a minus 2. Downstairs, a minus 3, a plus 3. So just copy those. You can check them later, but I don't want us to spend any more time today as a class factoring these things. But I would like you to cancel whatever you can cancel. So once you've got all those copied, go ahead and get rid of any fancy forms of 1. And if you need to bring in a negative 1 someplace, then do so. Yes. Yes. You can go straight up and down. That's okay too. Yeah, when we cancel, it's any numerator with any denominator. So the a plus 5s cancel. A minus 3s cancel. A minus 2s cancel. All that's left is a minus 7 over a plus 3. Questions on that? Victor. So the only time, okay, so technically every time we cancel things that are exactly the same, we're really thinking about an invisible 1, fancy form of 1, positive 1. If it's exactly the same as positive 1, which we don't bother writing. The only time you got to put that negative 1 in there is if it's the same, but like one has a plus and the other one has a, sorry, they're both minus, but in the other order. Yeah. Okay, last one, and then it's group activity, part D. Is the top factored? Let's do subtraction and addition, so it's not factored. Is there anything you can factor out of all the terms on top? There's no number, there's no m's in everything. And then finally, I see m to the 6th. Pretty much the only thing I can factor is m squared. So if I see anything other than m squared, and I've already tried factoring stuff out, there's nothing to do. So you can't factor the top. The bottom is already in factored form. It's just one term. So what can we cancel? Maybe the 5 goes into 25 5 times. Is that okay? Yeah, this thing right here is part of something else. You cannot selectively choose to look at the 25 and ignore the other stuff. Okay, so I can't cancel those. All right, you caught me there. But how about this? M cubed and m to the 4th gives me a single m left on top. Is that all right? Jirka? There's other stuff. You cannot selectively choose. Addition and subtraction, you cannot cancel, which means this one is already simplified. There's nothing to do. Okay, so you try factoring. If nothing cancels, then so be it. All right, next page. There's an answer key, but don't look at it until you've given your best shot. Work with your neighbors. Raise a flag if I can help.